Hi, my name is Rouven. As Jason just said, I work for Contentful. I actually based in the mothership, meaning Berlin, but our San Francisco office is actually right here in this building. And today I want to talk to you a bit about Amazon Alexa and this little dude, which is the Echo, which runs Alexa, and how you can program your own voice skills using AWS Lambda. And we're going to store the content in Contentful. Why? Because it's the easiest way to do it. A little bit about myself. My name is Rouven. I'm a developer evangelist, have been for a couple of months now. Before I was an engineer at Contentful, actually working on the product. But my experience with CMS systems goes back much further. I used to be a Joomla developer, actually on the core team, was fed up with CMSs after a while, said never again, until I found Contentful. And then I decided, like, oh, okay, maybe once more. So why do you want to speak to a computer? Or more importantly, why do I want to speak to a computer? Well, I'm a kid of the 90s. And as a kid, I watched Knight Rider, and I loved the show. Now, Knight is actually an 80s show. It just came out 5-10 years later in Germany, as everything did back then. And why was Knight Rider awesome? Well, first of all, it had David Hasselhoff. And we Germans, we just love our David.
Millston in Silicon Valley, 110 miles. All right. Might as well put on some music. All these weird gadgets, you think they'd give you a radio? What would you like to hear? What the hell was that?
Do you wish further information on Silicon Valley?
Hell no, I want to know who you are and how you're listening in.
There's no reason for increased volume. I am scanning your interrogatives quite satisfactorily. I am the voice of Knight Industry 2000's microprocessor, KITT for easy reference, a KIT if you prefer.
No, I don't prefer, and what's more, I don't intend to drive around in a car that talks back to me, so either Devin pulls your plug, or you get yourself another driver.
And this is actually the very first time kids spoke on TV. And it's a talking car. Wasn't it awesome? And it wasn't the only thing where movies said, like, talking to computers is really cool. And who knows this one?
Shall we play a game?
Okay, the hint is already there. It's Whopper from War Games, which you couldn't talk to, but at least it talked back to you. So talking with computers is awesome in movies. Because let's look at the reality as it were in the 90s.
Phone dial 555-1212.
Phone dial 555-1212.
Radio tune 101.1.
Radio tune 101.1 FM.
It's a breakthrough technology, a voice-activated control system for your car. And get this, you don't have to pre-program it, and it responds to any driver's voice. Unlike other voice recognition technologies, this Vistion system doesn't need to learn your voice first.
Doesn't need to learn your voice first. Revolutionary. But come on, that sucked. You had to only give it pre-programmed statements. When you want to give it a number, you had to give it individual digits. You couldn't even give it a full number. And it didn't have any state. You couldn't ask a question for clarification. You always have to give it full instruction. It's more like a really dumb dictation device than a voice interface. And this was pretty much the state things were at throughout the 90s and the 2000s. And then in 2011, the future made an appearance. It's actually a smart voice interface. You had to press a little button. They fixed that a couple of years later. But you could ask follow-up question. You could use natural language. You didn't have to conform to some awkward prompt system. It just was almost like talking to a computer that's unable to understand my accent. But otherwise, it's pretty darn good. And this was Siri, was really the first big one. And Google and Microsoft with Cortana followed up soon after. These tiny little devices we have in our pockets can do an amazing thing now. They actually understand us speaking. They can do it thanks to the cloud, but still they can do it in a very tiny package. And these three products all have something in common, unfortunately, and that is no APIs. And as a developer, that makes me really, really sad. Now, it changed a little bit. Google opened up in the last 2 years, Apple around the same time frame too, but there's still very limited APIs. They only give you access to a certain subset of things you can do, especially areas in the case of Apple, which can only give you certain intents. You can't do any of your own text-based things. As a developer, this sucks. I want to use this cool technology, and I want to build my own thing, and it wouldn't let me. This all changed when Amazon entered the scene and introduced the bigger brother of this little thing, the Amazon Echo running Amazon Alexa. And it had an API from the first day. You could build your own skill kit. Actually, what most people don't know, it has two APIs. It has a skill kit API and also has the device API. You can run Alexa on your own devices. If you build hardware, you can run Alexa on it. It's really cool. People have built crazy things. The creepiest I've seen is the talking fish, you know, that some old people have on the walls. It speaks to you. It's really, really creepy. But it runs with Alexa, and also because I have an open API. But today I want to focus on the Skills Kit API, because that's how you can actually get your content to be a voice skill. And to demonstrate, I first want to play a game. And for that, I need a volunteer. And you can win some swag. So who would like to play? Yeah, you. So, hey, what's your name?
Alex.
Hi, Alex. All right. So start HTTP quiz.
Welcome to HTTP Trivia Quiz. I will ask you 4 questions. Try to get as many right as you can. Just say the letter of the answer. Let's begin. Question 1. What's the meaning of the status code 418? A. Not found. B. Go away. C. URI too long. D. I'm a teapot.
C.
That answer is wrong. The correct answer is D. I'm a teapot. Your score is 0. Question 2. Which of these methods is the only one defined as safe? A. Delete. B. Post. C. Put. D. Options.
Can you repeat that?
Question 2. Which of these methods is the only one defined as safe? A. Delete. B. Post. C. Put. D. Options.
D.
That answer is correct. Your score is 1. Question
Good
3.
job.
Thank
The
you.
first documented version of HTTP had which version number? A. 0.1. B. 0.9. C. 1.0. D. 0.5.
C.
That answer is wrong. The correct answer is B. 0.9. Your score is 1. Question 4. Which of these methods is not idempotent? A. Put. B. Patch. C. Head. D. Get.
One more time, please.
The correct answer is B.
You have to say repeat.
Out of 4 questions correct.
But still, really good job, Alex. And you have the choice between a pair of socks or a cardboard. Socks. He knows what he wants. All right, good job. Thank you for playing. So I just accessed content that lives in the cloud. I was not completely smart enough to anticipate what people might say, so I said actually, oh yeah, if you say repeat, you probably want to hear the question again. I didn't expect people to say one more time, please. That's then for version 1.1. But this is something you can build in an afternoon. How does it work? Well, all the content is stored in Contentful. So I have a very simple schema. There's just a question. A question constitutes of one question, one correct answer, and as many incorrect answers as you want. I'm running code, JavaScript code, on AWS Lambda. First of all, it's the easiest way to get some JavaScript up and running in the cloud. But also, since both are from Amazon, it's natively integrated with Alexa. So I don't have to set up any webhooks for it. I don't have to take care of HTTPS authentication. All of that Amazon gives me for free. And then Amazon Alexa, of course, is the Voice Skills API. And now I want to do this live, and I hope it actually works. So I'm going to reuse the same space I just created. So you can see it here right now. The space has this one content type with a question, and it has a couple of questions here. I'm not going to create a new one, but I am going to create a new skill that's going to need a slightly different name, because otherwise they would clash, because all skill names have to be unique. This right now runs in the private development mode, so I don't have to care about namespace clashes with other private developers. But once you make a skill public, it has to be unique, usually containing your company's name or your product name. Otherwise, it will be rejected by Amazon. So this is the Amazon Developer Console. It's not the AWS Developer Console. For some reason, it's actually separate. I don't know the reason. And here I define what a skill actually is. So first of all, my skill has a name. Since we're in San Francisco, let's call it San Francisco Quiz. Francisco, no, it's spelled correctly. And it's an invocation name. Invocation name is what I used in the very beginning to start the application. The demo has start HTTP quiz, so I can't use that again. So I'm going to instead say start San Francisco quiz. Start is already the given thing from Amazon. So I'm just going to go with San Francisco quiz. All right, I don't have an audio player, I don't have a video up, and I'm not going to render any templates. So this is good. All right, now I have my skill created. Now I need to define it. Now, to get started, I don't want to build the full skill, otherwise it's going to be very confusing for you. I want to start with something a bit more simpler, something that just tells me a fact. So for that, I'm going to define an intent schema. An intent schema lists all the things that might be said by a user of your skill. Doesn't mean all the different way of phrasing that thing, but all possible invocations. And this is simple JSON. So I'm going to have a property called intents. So get new fact intent is the skill, the intent we're actually custom defining. And then Amazon gives you some intents on the house. We're not really going to need them right now, but just to give you an example of how this could look like, there is, for example, the Amazon yes intent. So now Amazon by itself is going to know all the different way people might say yes to a computer, and just going to do that for me without me having to define it customly. Why is that a big deal? Because Alexa is very convincing, but it's actually surprisingly dumb. All it does is pattern match. So I now have to list every possible way of how you might ask for a fact. So for example, I might say a fact. I was going to copy and paste this because I'm going to be typing it a lot. I might say, tell me a fact. I might say, give me a fact. You feel where it's going? I might say, tell me trivia. I might say, give me something. Yeah? It's really, really dumb. There's very little inference of these phrases. You basically have to list out everything you need. I know people who have written skills with over 1,000 phrases ending up in this file. Because once you start doing user testing and you think, oh, I found every possible way of how people are going to say this, and I have 200 phrases, I'm good. Users will find new ways of how to say things that you did not anticipate. And here, user testing is really, really important. Otherwise, people are going to have a hard time using the skill. All right, let's get going with this. Please wait while the skill is updated. All right, so I already took the liberty of setting up an AWS Lambda function. So I'm just going to copy and paste the ARN, the Amazon resource name. That tells me actually. Good cheat sheet. There's an optional feature to have Lambda functions running in multiple locations so they're closer to your user. We're not going to make use of this today. And we don't need any permissions on the device. All right, and now I got my skill set up. It's still compiling the interaction model for some reason. All right, now it's done. So now we got to write some code. I set up this little boilerplate, and we're going to use the Amazon Alexa SDK, which is kind of necessary for more complex skills. For a simple skill like this, you could do without, but to introduce a concept, I'm going to do it with the whole thing. So first, I'm going to need to set it up. Oops, const Alexa. And what the SDK does, it's based on handlers. So I have to pass it an object. I first have to create it, and I do that by giving it the input I get to my Lambda function. This here is a signature that every Lambda function has. That's defined by Amazon. So first, I'm going to create my Alexa handler. Next, I need to register some handlers. Yes, this is very confusing because they're using the same word for two different concepts. The handlers is simply a JavaScript object. I'm going to call this handlers for now. And I'm going to define it in a second up here. Const handlers. All right. Semicolon, so my IDE doesn't complain. And then, last but not least, I need to tell the Alexa SDK to execute. Execute. All right, that's the basic setup for the Alexa SDK. Now, to actually do anything, I need to map it to the intents I defined earlier. So earlier, I had a get new fact intent. So now I have to write the handler for this intent. And in this case, it's going to be a simple function. And then every handler has access to this. And on this, there's a method called emit. And emit is me telling Alexa to do something. In this case, I wanted to tell something. And anybody has a cool fact they want to hear Alexa say? Well, let's going to go with grass is green. That's a cool fact, right? All right, and then the other one is the launch handler. That one you should always define. That is when somebody launches your skill without actually saying anything. So in this case, I'm just going to copy and paste everything I have here because it's the same thing. All right, now let's publish this to the cloud, and I got a little script for this. Go up, zip everything up, push it to AWS, and let's hope this works. Start San Francisco quiz.
Grass is green.
Woo! All right, that's not how it's supposed to work, but it does work. All right, so that's the most basic skill you're pretty much going to write. Now, of course, for this, we want to have something a bit more interesting. But since a lot of code and the meetup is very short time, I have something prepared. So let's rename this to basic. And this is my new index. Factory name. All right, let's make this a little bit bigger. All right, let me get you through what I've pre-written first. So this is the same we had earlier. This is just loading some helper libraries. Same here. I got a Contentful client pre-configured to access my space. And I have some messages pre-written, so I don't have to type out a lot of words. Now, this thing is a little bit different in that it actually has a state. So we talked earlier about how a good skill should be stateful, so you can ask follow-up questions. And this is implemented here. So this skill has three different states. It has this trivia mode, which is the main mode when you actually are in the game. And in the middle of it, it has a start mode, which is the very first questions it asked you. And we have the help mode when you want to ask for the rules. Now, we said earlier that we have handlers defined here. You have to have a handler for all of these states. I've pre-written most of them, so I don't have to do this here. I got my handler set up here again, and I have two functions still to write. I have to write the start game function, and I have the handle user guess, which is used in a trivia state handler. It's extracted as a function because it's actually used in a couple different ones, depending on how you invoke it. All right, so when I start the game, the first thing I always want to do is I want to start by defining some of the speech I'm doing. So let's start by let speech output. Now start game gives me a variable is new game. This is just there so whether it's actually the very first question you asked, the very first speech, or whether it is after asking for a repeat of the opening, because I don't want to repeat the entire welcome message. All right, so if it's a new game, I want to get the welcome message, which is also predefined. Isn't that nice? If not, I'm just going to give you an empty message here. All right, so that was the most easy part. Now I actually want to get some questions. To do so, I'm going to go to Contentful, and I'm just going to get all questions. This is not an inbuilt function of our SDK. This is my abstraction I built on top to make this whole thing a little bit quicker. Contentful's SDK always gives you promises, and it's really the best way to work with asynchronous programming in JavaScript. So we're going to use those here. Now I have all my questions. Next thing I need to do, I need to initialize my game state. The game state is later going to be passed around to an inbuilt function of the Alexa SDK. So it actually gets passed to me every time this function is invoked. AWS Lambda functions are stateless. You have to pass all the information you need in every request, or you have to access them from some kind of database. The Alexa SDK takes this, or makes this for us all work. We just have to define what we want to store. And to do so, I got this init function. All right, so I'm init the game with the items. And another typo. All right, so the first thing I need to know, I want to ask you questions. What questions do I actually want to ask you? So let's ask for the current question. All right, and that is state get current question. And I again have to pass it the items. Next is the concept called the reprompt text. The reprompt text is used when you downspeak. When Alexa asks you a question and you downspeak for a certain amount of time, it's going to reprompt you. As a best practice, you don't want to repeat the entire text you just said. You just want to give it a shorter version of it that just invokes the action from the user to actually do speak. So my reprompt text in this case is going to be the question text. So in case they forgot what the question is, they can just wait a little bit. And for that, I'm just doing this here and then current question. Now my speech output, the very initial thing I say, obviously should also contain my, my question. So I'm just going to take the speech output and append to it. All right, I talked earlier we need to have this, the state passed. For that, there is a magic variable, assign, that's called this attributes. Attributes. I really can't type. Object assign. Thank you, Ricardo. And I'm gonna need to have the state. And I'm gonna have the reprom text in there. Typing today is not my thing. And I need the correct answer text to be able to tell the user later whether the answer, if they said the wrong answer, what the correct answer actually was. For that, I'm giving it the name, correct answer text, and I'm getting that information from the current question again as the correct answer text. All right, so this is all the data I need. What I still need to do, I need to tell it what's the next state. Right now, I'm in the start game state, what's called here start mode. That's defined here, because it's the handler for the start state. Now I need to make a state transition to the next state. To do this, I say this handler, and the state is game state trivia. This is just the reference to this text here that I'm entering the trivia mode. That being done, I want to emit and tell the user actually what we just defined. Again, I'm going to use tell. No, actually, this time I'm going to ask, because I actually want a response. The difference between tell and response is, if I use tell, like I just used for the fact, it's going to close the connection immediately. It doesn't wait for a follow-up. If I use ask, it actually waits for me to say something else. So since I'm asking a question, I kind of want an answer for it. I do want to ask, and I have to give it the speech output and the reprom text. And then, being a good programmer, I'm not forgetting about error handling. So I'm going to log the error. And this is already the start mode. So let's see if this actually works. Start San Francisco quiz.
Welcome to San Francisco quiz. I will ask you 4 questions. Try to get as many right as you can. Just say the letter of the answer. Let's begin. Question 1. Which of these methods is the only one defined as safe? A. Put. B. Post. C. Patch. D. Options. There is a problem with the requested skills response.
So since we only influence the start mode, it doesn't know what to do next, and anything that happens. So it would have gotten to the reprom text, but Stefan was louder. So it thought it was an answer. It didn't know how to process it. So it bailed out. All right, let's mute this again. This takes a long time to mute. And let's actually handle the user guess. This is really the meat of the whole thing we're building here. So to start with, I need to get my state again. Since the state is passed, again, as a new invocation, I can't store it in some variable. I actually have to decode it from the attributes again. Again, I've written a little helper function to do this in this case, which I'm calling const state, helper decode state, and it's coming from this attributes. I'm just going to cheat here, which is the same as what I used earlier to actually assign the state. All right, so same deal as before. I want speech output, which is just going to be an empty string for now. And what I, in this case, I also want is the analysis of whether the question answered was correct or wrong. So this we're going to call, speech output analysis. All right, also going to be an empty string for now. Now, what do I need to do? Well, first of all, I need to know, was the answer given actually correct? To do, state has a helper function. Is answer correct? And to this, I have to pass the intent of the request. The intent is all the information given to me through speech by the user. And again, I can access this through this event request intent. I will say Alexa's SDK is very verbose. There's usually a lot of typing involved to get to certain information. All right, answer is correct. In this case, let's increase our score by 1. And the speech output analysis is going to be that the answer is richtig. Since I'm German, I think I can use that. Notice how I'm ending it with a space. Since building these responses and questions is mostly a lot of string concatenation, what I discovered is it's best if I always just end with a space. If it's the last thing I do, it gets ignored by Alexa. If it's something appended, I don't have an awkward situation where there is no space and Alexa thinks it's one word with a dot in the middle. All right, this is this condition. The alternative I'm going to code as an else condition. And here I want to actually know if the user gave up. Whoops. Not the mode I want to be in. If not, user gave up. Then I'm going to say falsch. Even learning some German today, isn't it great? And we do want to give the user the opportunity to learn what the mistakes were. So we're going to append the correct answer. And for that, I got a precant message, which we access like this. All right, and so now this is the basic handling of, hey, is this actually correct or incorrect? Now, the next thing I need to check for in this little game is if the game is actually over. So we're doing this. And again, I'm just manipulating my speech output. So, oops, if the user gave up, then I'm saying nothing. If the user doesn't give up, but just made a mistake, I want to actually help him out and tell him if his answer was correct or not correct. That answer is. All right, next up, I'm going to append. Typing is really, really hard today. The speech output analysis. And there's an endgame message that I also want to give them. And for that, I have to access the score once more. All right, so this is pretty much everything I want to tell the user if the game is over. So how do I tell something? Who remembers? Nobody, disappointing. This colon tell and my speech output. Notice this time there's no reprompt text. Since I'm using tell, Alexa is just closing the connection as soon as the speech is done. And I don't have to give the user the opportunity to listen for a reprompt. Now, if the game is not over, we need to play a second round. So to do that, the easiest thing to do is just to play a round. Helper methods are great, aren't they? So one thing I need to do is, again, I need to get the question from Contentful. In this case, I need just one question. So I'm just querying Contentful for one question. State get question ID. The reason why I'm not just fetching all questions again is first of all to save bandwidth, and second of all, otherwise I would have to write some code to filter for the correct ID. It's much easier to do it like this, and it's even better if I don't do typos. All right, this is once again a promise. So we're getting a promise out of this again. My response is going to be the current question. So I'm passing that to my array, to my function. All right, and now I need to actually construct a question again. So the first thing I'm doing is I'm going to define my reprompt text. And in this case, the reprompt text is just going to be the question again, which I've written before. So let me copy and paste this, so I don't make any more typos. All right, so that's my reprompt text. The speech output needs to contain the things I had it earlier contain. So I'm also going to copy and paste this line. Yes, there's an opportunity for some refactoring here. And the other thing I want to tell the user is what its current score is, so they can keep track a little bit. This is, by the way, wrong. To do that, again, I'm appending to this. And I'm giving the analysis I had earlier. And I'm telling them what their score is. So in this case, that answer is... wait, no, that's wrong. I'm skipping a line. Sorry. Your score is, and then the score. State.score toString. All right. Last but not least, I need a period, a space, and I need the reprompt text. So far, so good? All right. Next thing we need to do, we need to, again, store everything in our state. State management is super important. It's also super tricky. I think most of the bugs I've ever had in this project were some things not ending up in the state where I want them to, and then trying to figure out, is this something Alexa messed up? No, it's never. Or is something Rouven messed up? Yes, it is. So again, I'm going to emit a question. This time I'm asking again. And I'm just giving it the speech output. Not the output speech. Speech output. And the reprompt text. Reprompt text. All right. Space before the score. Let me do an error handling. Speech output analysis. Whoops. Should have a space at the end. It does. All right, so you can see this here. After your score is, oh yeah, there it should have. Thank you. All right, so this should now work. Let's deploy it. And who wants to have the chance to win some swag? Come on. What's your name?
Christian.
Hi, Christian. All right. Do you know HTTP?
Yeah.
All right.
A little bit.
Do you have a good memory?
That I do.
So you can just remember the answers. All right. Start San Francisco quiz.
Welcome to San Francisco Quiz. I will ask you 4 questions. Try to get as many right as you can. Just say the letter of the answer. Let's begin. Question 1. The first documented version of HTTP had which version number? A. 1.1. B. 0.9. C. 2.0. D. 1.0.
I think it's B.
There was a problem with the requested skills response.
All right, so that's my bad, not yours, so you get the swag anyway. One important point I want to make is defining voice interfaces is not like designing other interfaces. It's not like visual design. It's also what many programmers like to believe, it's not like defining text interfaces like a command line interface. A command interface is really that old 90s style prompt based. I'm going to tell you exactly what you do, and you're going to do it. It doesn't, well, it actually sometimes asks for clarification. It might prompt you for an answer, but it's not going to infer from natural language what you're doing. It also doesn't consider that people might say like, and other things to mean agreement or a no. Natural language works very differently than computers do. The best book, actually the only good book I found so far on these unique challenges is Designing Voice Interfaces, Voice User Interfaces from Kathy Pearl, published by O'Reilly. It's not very thick. It's 150 pages. I strongly recommend it if you want to implement this in your team. Give this a read yourself, give it to your designers, give it to your product people, and figure out what the interaction actually should be, and don't just dump some data into a voice scale. And now, go build some voice interfaces. Thank you very much. I hope you enjoyed this.